So as we begin here, what is a right angle? What's definitionally, when I say right angle, what am I saying? What was that saying? No. No, sorry, no isn't a right angle. What's right angle? It's nothing. No, right angle isn't nothing. It's zero. It's not zero. It's oh yeah, that's 90-degree angle. Hey Evan. Welcome. So 90-degree angle. I should mention, today we were talking about maybe doing this assessment block, Evan. Do you have something we need to caught up on next week? Missing assignment. Now, a couple things definitionally about triangles. So, if we named it triangle ABC by the angles, then notice here, the opposite side from the angle has that same letter. So like, uppercase B is opposite from lowercase b side. Uppercase has the angles, lowercase has the sides. So we could call this triangle ABC, and that would tell you the angles are ABC, but also the sides are ABC. And the interesting thing is, until grade 10, we would have called this side AB. That's still true, but if we're using one small letter, it's C. Just remember, if we're using a small letter, it's from the opposite angle. Okay? Other pieces of this. Whatever is opposite the biggest angle, in this case the right angle, is the longest side. Whatever's opposite from the smallest angle is the shortest side. And when we're talking about using like our trig ratios, when we name them hypotenuse, adjacent, and opposite, the hypotenuse is always the longest side. Now these opposite and adjacent are in relation to some angle. So if we're talking about angle theta here, we're talking about angle theta, which for some reason, that's like a Greek letter that's very often used for angles. Don't know where that started from. But if this Greek letter is the one that's most often used to be opposite from a side, or to be the angle, sorry, the one that's opposite it is the opposite, the one that's beside it is the adjacent. If we were using this angle though, then we'd be talking about opposite and adjacent, right? So it's in relation to some angle. Okay. Now there's a few different ways we can solve for missing things on angles. So let's take a look here at this first one we know about, Pythagorean theorem. Pythagorean theorem, we learned that one in grade 9. It's really useful if we know two sides of finding another side. We know that the two sides squared equals the hypotenuse squared. And this can be rearranged. We could say also, a squared equals c squared minus b squared. Or that b squared equals c squared minus a squared. Basically the premise that the square of a and b together is equal to the square of c. Probably all seen in demonstrations, and review demonstration to show how they are the same size squares. So let's think about how we use this. So using Pythagorean theorem, if I look at I have triangle ABC where I know the two sides and I don't know the hypotenuse. And I remember that c squared equals a squared plus b squared. Okay. And I was given these side lengths. It's for grades. Oh man. Well, fortunately for you, I have mine. That library. Fortunately, you can get it there. Alright, so what should we call A? If I'm substituting numbers in, what should I call A here? 4. Sounds good. 4. Now, technically, I know it doesn't actually matter in this case. Technically here, A is 7, B is 4. In terms of the sides, they are interchangeable as long as we keep the hypotenuse straight. But if we're wanting to follow the actual language here, A is opposite from 7. So we have 7 squared plus B is opposite from 4. 4 squared will equal 6 squared. Okay. Now, we had a little bit of trouble in our last unit with squaring numbers. What's that mean again? So what? What is it squaring? Exactly. It's not multiplying that by 2. It's multiplied by itself. I noticed yesterday, even on your unit exam, there's still some people seeing a squared and going times 2. No, times itself. So this means that c squared equals 49 plus 60 or 65. And the most common mistake we'll see here, then we say, oh, okay, good. This side is 65. No, it's not! Right. That's what c squared is. That's what c squared is. So if c squared is 65, square root both of those. Square root both of those. Square root of c squared is c. A squared is 65. Right. It's just bigger than 64. 64 is 8. So 8.06. Let's just call it 8.1. Nice. Okay, this next one. Same setup. Oh. What happened there? Ah. This next one, I still have my two side lengths. I'm looking for my hypotenuse. This is a Pythagorean triple. Might make it a nice kind of number. Give B a try. See if you can find your side C. Give it a console. I will suggest for this unit, just like the last unit, you're going to find most of this quite hard without a calculator. Some of you guys have magic square root powers, but most don't. Give this a try, please. I want you writing down the missing side lengths. How about the one right beside? 4 squared. 4 times 4. 7 times 7. A gift. But a gift at all. What's it? Hey Emma, welcome. You are another one who looks. Give you another minute here, guys. Okay, am I right to think that c squared is still equal to a squared plus b squared? I hope so. Nothing's changed about the Pythagorean theorem since the last question. Good. And in this case, a is 8 squared, a squared is 4, and we have 6 squared here. That's almost unfair, hey? B ends up being 6. Substitution that looks the same. Okay. Okay, so we can say c squared equals 64 plus 36. Oh, that's very nice. 100, which is a perfect square. Nice, great insight. So c squared is 100, which means if I square root c squared, square 100, c is 10. Now, some famous combinations of numbers we call them Pythagorean triples is where the two numbers that we use for a and b end up giving us also a whole number for c. So 3, 4, and 5 is the smallest example of that. Anytime where you're having a multiple of that, you'll have another Pythagorean triple. So 6, 8, and 10. Or if you had 9, 12, and 15, it's another example. Those are nice ones. Okay, this next one, C. I'll walk you through here, just because this is a slightly different setup. You guys saying? Sam, are you checking this one? You check this one?
Yeah.
I was just curious if you were trying to okay. Okay. So this next one, you'll notice here, we have the hypotenuse given to us. So if I had written out here, c squared equals a squared plus b squared, remember how in the last unit we would often say, okay, which variables do we have, which don't we? Well, here we have c and we have b, but we don't have a. So maybe we want to rewrite this formula right up front and say, oh, okay, I'm looking instead for a. A squared equals c squared minus b squared. Type the hypotenuse I have, I'll subtract that from one of the side lengths. Or I could say a squared equals. We always say opposite from the angle is the side length. That's how we name them. And what I mentioned before here, I'm not too worried. It's not like I'm going to mark you wrong if you mix up A and B. Those are just the two arms. The thing that really matters is which one is C, right? Which one is C. Okay, so A squared is equal to 13 squared minus 5 squared, or 169 minus 25. Wait, 13 times 13, 5 times 5. Oh, it is 169. Most of us probably know the, like 1 times 1, 2 times 2, 3 times 3, 4 times 4, kind of up to 12 times 12. I found generally by 13, many of us don't quite know those. 13 times 13 is 169, 14 times 14 is 196, 15 times 15 is 225. Those will be really common ones also.
Square root is 13.9.
Yeah, just noticing here, 169 minus 25. Oh, we have another perfect square. That's super nice, right? A squared is 144. So if I square them, yeah, nice. That means that A is 12. Nice, that's great. A is 12. Okay, last one. This time I have C again, and I have A. B squared equals C squared minus A squared. Welcome. Najara, we'll have you do your missed exam early next week. Okay, actually. So B squared equals 25 squared minus 20 squared. All right, 25 times 25. 25 times 25.
625.
Nice, good one. 625 minus 100.
400.
225. Oh, I think I see another perfect square. Nice. So B squared is equal to 225. Square root of 225. Thank you, Ariana. B equals 15. And you'll probably notice, I most often, even though I sort of answer it like this, I find filling in the triangles just another way of sort of labeling what we've got, right? This is sufficient, it's fine. But why not just go in and kind of complete showing the triangle? In terms of just organizing your work, these are two nice ways to show I've completed this, right? I know all pieces of the triangle, and I've answered what was asked. Okay? Now, on this next one, what it's asking us to do here is just label which one goes with which. And I'm just going to show you how we would look at it. So if I know this is angle A, this is side B, this is side C. Angle A, side B, side C. How do I fill in the rest of the letters? What's the rest of this triangle? First of all, what are the other two angles? I have angle A. Where does side B, or where does angle B go, sorry?
Angle B.
Right. Yeah, across from side B, or the other one that's not the 90-degree angle, which leaves C here. So now I just have one side to label, and I guess it's kind of obvious. What name is that side?
Okay.
Yeah, right. Okay, how about this one? How about PQR? PQR. Where's angle Q? Well, duh, the only angle is missing. And how about the sides? Which one's R, which one's P? What's the hypotenuse? Yeah. So what's the name? Just call it R. Okay. Opposite angle R. Okay, I'm going to give you just 5 minutes here. Finish labeling C, then work on trying to do Pythagorean theorem for these 3 triangles, just like what we just did. Okay. Take a moment to think about the triangle, please. Let's say 948. Students. Do you want me to back up something that will
Okay, so the first one, translate it for this, so I can write down my so I'm gonna say
I thought it's because you drink too much monster or something.
I have it. Hypothesis is always one of the six. It's the one that's opposite from the angle. So I don't know. This would be do this. So do that. This and this two angle that we want. So this we should also have. Now one more time. 30. Just opposites of opposite ends. Plus 4.
It's not that hard.
Just use so I got kind of do that. Oh, that's what it's like he's charging. He's getting to his power. I thought it should be.
Maybe it's like brain talent.
Yes, welcome. Just your guessing. It was on this video. It's not. Oh, they're gonna speed running away. You did this in grade, most likely grade 9. What's that? What's that? You know how you do this? You know how? We did in grade. So you got C squared is under. I calculated for it. And now what do you do? I got a 0. I'm failed with the 18. I failed with my PhD. Yeah, you want to take 0 out of 20. You can take another.
I don't even know what I got.
And then you don't
Okay, that's percent on us. We have 50. The
rest of
yeah, I know.
I wasn't told. That's why I have to work. I was the only reason my existence is grade, my final grade for the whole year was a 30. I went to radar. Higher equations for me and my studies back. Okay. How do you looks like 1, 2, 3 repeats? No, it's probably. Oh, I use that. They got shut down. That's the same. It's like the last one. Grading class. I'm so here now. I did a big. Boom.
Which school did you go to?
I went to Everett.
Oh,
I
I don't know that school.
Exactly. Like it was a long grade 6.
Oh, so it's like an elementary junior high? What's a JP?